Hello and welcome to yet another thrilling installment of the pre-calculus videos. This is Unit 4 and this is Section 2 and this is operations with complex numbers. So we want to identify, and perform addition, subtraction, multiplication of complex numbers. So we have these complex numbers, a plus bi, where a and b are real numbers. I is the imaginary number. We can add them, we can subtract them, and we can multiply them, and such as. So they also work, we also need to know the properties of the commutative property, and commutative, remember, means reorder. So we can reorder them. Let me get a good pen so we can reorder. Okay. Associative property means we can regroup. Okay. And then distributive property, we know that. The identity property, means keep the same. Keep the same. And then the inverse property either means we add to 0. Add to 0. What do we have to do to add to 0? What do we have to multiply to get to 1? Okay, so that's the idea. All right, so you need to know those properties just as, the basics of what we're trying to do today. And so what we do here, we want to make sure that we understand these properties. And so it says, which property allows you to write the expression 3 plus 7i plus the quantity 8 minus 6i as 8 minus 6i plus 3 plus 7i? And that would be the commutative property, okay? Because we are just changing the order. We've just flipped these two. Okay, so this is commutative, okay? And then here, we've got this group of 3 plus 7i and 8 minus 6i, and then plus 1 plus 9i. And then they've got 8 minus 6i plus the grouping of 3 plus 7i plus 1 plus 9i. And that's just going to be the associative, okay? The associative property. All right, so understand how that works, okay? And then it says, given something like this where we've got, which property allows 3i plus 2i to be written as 3 plus 2 quantity times i. And that's the distributive property. Okay, and all you've done is you've actually factored out an I from each of these. Okay, so distributive. Okay, and what we can do if we add those together, if we take 3 plus 2 and add it together, we get 5i. Okay, so adding imaginary numbers is just kind of like combining like terms. Combining like terms. Okay, so in general, if you were to take AI plus BI, okay, we can't really combine those because we have variables for our constants. So we have to just factor out an I here and leave it as the sum of A plus B all times I, okay? All right, so let's take a look at something like this where you want to add these two complex numbers. So what I do is I kind of think about it as like terms. I'm just going to take negative 12 and 9. So I'm going to rewrite this as negative 12 plus 9. And then I've got 4i and then negative I. So I've got plus 4i and then minus an I. Okay, so I'm just going to add these common terms together. And so I've got negative 12 plus 9. That's going to give me a value of negative 3. And then plus 4i minus an I is going to give me a 3i. Okay, and that's it. That's the answer. That's what I'm looking for. So not too bad. Just, be able to, go through that. And, we can go all through all this crap. But, I'm just going to combine like terms just like I did in the last one. So I'm going to rewrite this as 3 plus negative 2. And then plus, we've got negative 5i plus 8i. So negative 5i and then plus 8i. Okay, so then if we've got 3 plus negative 2, that's going to give me a value of 1. And then plus negative 5i plus 8i is going to give me just a positive 3i. Okay, so nothing major, just combine like terms, just like you would if you were adding variables. Let's take a look at this. Wait a minute. Oh, I see it's already just got there. All right, let's move on to the next page. Okay, let's talk about subtracting complex numbers. And, it kind of goes along the, this notion here where when you subtract a complex number here, all right, you want to make sure that you distribute the negative. Okay? So if we were to do it on this one, to really subtract this one, we'd want to really make sure we, distribute this negative here. And so I'm going to rewrite this as 10 minus 3i. And then if you have negative 6, it's just going to be a plus 6. And then negative 7i, so we're just going to subtract 7i. Okay, and then again, we're going to combine just our like terms, or we'll do 10 plus 6 plus negative 3 and negative 7i, so minus 3i minus 7i. Okay, and we should get as a result, 10 plus 6 is going to give me 16. And then plus, well, I don't want to do plus. We can just do minus a 10i. Okay, and that would be our answer. All right. And, you can sit here and do all this crap that they're asking you to do, but that's the idea. So, but if you look at this, I do want to answer this question. So we want to subtract these two numbers. Let's just go ahead. Did we already do that? No, we didn't do that one. Okay, so if we do this one, we want to distribute the negative, okay? And it says which property allows you to write it like that. So if you've got 5 minus 2i, and then minus 1 minus 8i, okay? The reason why I could write that was because I distributed, all right? And so then if I come back in here and I combine my like terms, 5 and negative 1, so if I've got 5 minus 1, and then plus negative 2i minus 8i. 5 minus 1 is just going to give us 4. And then plus, I don't need to do plus. Let's do minus negative 10i. So minus 10i. Okay? And that's the answer. All right? And that's what we're looking for. Okay? All right. Now let's talk about this, finding the additive inverse. The additive inverse of the complex number is when, if you have a plus bi, the additive inverse that would bring it back to 0 would be, negative a and negative bi, okay? And if you add them together, it'll give you 0. Let's just, do that one real quick. So if we had, 5 minus 5, okay, and then plus 4i minus 4i, okay, this part here would add to 0, so you just get 0, and then plus this part here would also add to 0, so you're just going to get a value of 0. Okay, so then over here it says what is the additive inverse of negative 2 plus 8i? So I just want to do the opposite. Even though, this one's negative and this one's positive, I would want the value, this would have to be positive 2 and then minus 8i. Okay, so it would be this one. All right. Let's take a look at multiplying imaginary numbers. Now, when I multiply, guys, the important thing that you understand when you multiply is you can reorder things. And that makes things a lot easier for me. So what I would do is this. I would say, okay, I'm going to take 3 times 4 and multiply that by I times I, okay? And now I can multiply the 3 and the 4 together, and that's just going to give me 12. And then I times I is going to give me I squared. Now, remember what we learned in the other one is that I squared is equal to negative 1, okay? So then this becomes 12 times negative 1, which just gives us negative 12, and that's it, okay? So it is kind of interesting when you do multiply imaginary numbers, you do end up getting a lot of numbers usually, okay? So, on something like this, if we multiplied, say negative 2i times this other complex number, 6 minus 7i, we would distribute the negative 2i, okay? Which is what has been done here, okay, on this one. And so what we end up getting, and let's reorder this so it's going to make a little bit better sense. We're going to do negative 2 times 6, and then times an I. And then I'm going to do this. Because this is one big quantity, it's kind of tricky because you got a bunch of negatives in here. But that's one big quantity. I'm going to go ahead and just multiply out these negatives. So I would say negative 1 times negative 2 is going to give me positive 2. So I'm going to do a plus 2 times 7 times I, okay? Now, as a result, this is what we're going to get. Okay, I've got negative 2 times 6. That's going to give me negative 12i. And then plus 2 times 7 is going to give me 14 times I squared. Okay, now remember, I squared is equal to negative 1. So as a result, this becomes negative 12i plus 14 times negative 1. Okay, and so we end up getting this as a result. Okay, my first number is going to be negative 14 and then minus 12i. And that's what happens after you multiply. So it does involve quite a few extra steps. And if you can skip steps, then, by all means, and then just go ahead and do that. So, okay, on this one, it says, which of the following is equivalent to negative 2i times 6 minus 7i? And, and the only other way to write negative 2i is if we put a 0 out here and said 0 minus 2i. So this would be our answer here. Okay. And then, yeah, okay, I guess we already did this one. What was that? Negative 14 minus 12i? Okay, so, whatever, this stupid question. Okay, so sometimes you don't always just have, a one-term complex number, and then you have these these complex numbers that are in the form of a plus bi. And if we were to multiply these together, then we have to use the FOIL method, which is, using the distributive property twice. But what I want to do is I'd want to multiply the first numbers together. So I'm going to do 8 times 3. So my first numbers, not firsts, first. Okay, and that would be 8 times 3. Okay, I'm going to do my outside, which is 8 times negative 7i, so 8 times negative 7i. And then my inside, okay, that's going to be 3 times 4i. Okay, and then my last is going to be 4i times negative 7i. Okay, so when I do this, okay, I'm going to get 8 times 3, which is 24. 8 times negative 7i is going to give me negative 56i. And then 3 plus 4i is going to give me 12i. And then 4i times negative 7i, that's going to give me negative 28i squared. Remember, I squared is equal to negative 1, so this is really just going to give me negative 28 times negative 1, which gives me positive 28, okay? So now what I want to do is I want to add all of these numbers up and figure out what we get. So I'm going to kind of put them in like term form. I'm going to do the 24 plus the 28, okay? Because those are just numbers that I can combine. And then I've got minus 56i and then plus 12i. Okay, so if I do 24 plus 28, that's going to give me 52, okay? And then if I do negative 56 plus 12, that's going to give me negative 44i, okay? And this is my new number, all right? And so now, I've got that as my, and that's the thing. When you multiply two complex numbers, you're going to get another complex number. Okay, so let's try this one more time, just to kind of do this again. I'm going to multiply the first ones together. So my first ones is going to be 2 times negative 1. My outside terms is going to be 2 times 4i. My inside terms are going to be negative 7i times negative 1. And then my last terms are going to be negative 7i times 4i, okay? And so, let's just kind of put these all together. This is going to give me negative 2. This is going to give me 8i. This is going to give me positive 7i. And this is going to give me negative 28i squared, okay? Which, again, is going to give me negative 28 times negative 1, which is going to give me positive 28. So then I want to add up all of these terms, okay, and I'm going to put them together so that we have like terms, but I'm going to put negative 2 plus 28 and then plus 8i plus 7i, Okay, so negative 2 plus 28, that's going to give me 26. And then 8i plus 7i is just going to give me plus 15i. And that's my answer. Okay, notice again that we are getting another complex number from doing this. Okay, all right, so then, you know, I do want to talk about complex conjugates because, you know, it is important that we do this because sometimes we will have to, what am I trying to say? You know, get rid of the I value, okay? And the reason why, and we'll kind of go over the reason later, but let's just remember that if you had conjugates, it's the product of a sum and a difference. So if I have 7x plus 2, then the conjugate would be 7x minus 2. So these two things are conjugates, okay? And so, you know, when you multiply this out, you get, you know, 7x times 7x is 49x squared, minus 14x plus 14x, and then minus 4. Now, the point about this is the middle terms add to 0. Okay, those go away, and you end up getting 49x squared minus 4. Okay, but if you have a complex conjugate with a complex number, meaning complex conjugate, let's multiply these out, and this is 7 plus 2i times 7 minus 2i. And so, you know, if I were to FOIL this out, so my first terms, 7 times 7, which gives me 49. My outside terms, so would be 7 times negative 2i, which gives me negative 14i. Okay, my inside terms, which would be 2i times 7, would give me positive 14i. And then my last terms would be 2i times negative 2i, all right, which would get into giving me negative 4i squared. Remember, I squared is negative 1, so we get negative 4 times negative 1, which gives me positive 4. Okay, so now let's kind of add all these together. Okay, if I took 49 plus 4 minus 14i plus 14i, okay, 49 plus 4 is going to give me a value of 53. But the good part about this, and the reason why this is a really powerful thing, is that when you have negative 14i plus 14i, that adds to 0. Okay, this becomes 0, so the only thing that you're left with is 53. So when you multiply complex conjugates, you really get rid of I, okay, which is kind of the nice thing, and it's a really useful algebra trick, you know, down the line, okay. And let's just go ahead and do these real quick. You know, and I'm going to multiply these together. I've got, this is going to give me 9 plus 24i minus 24i. Those add to 0. And then we get minus 64i squared. Okay. So then, you know, these two terms add to 0. We're left with 9 minus 64 times negative 1. So that's going to give us 9 plus 64, which is going to give me a value of 73. Okay, notice how we got rid of the i's, all right? And that's the point, okay? If I do this one, if I do 4 times 4, we're going to get 16, and then we'll get negative 20i, and then we're going to get plus 20i, and then we're going to get minus 25i squared. So as a result, the negative 20i and the positive 20i, those add to 0. We are left with 16 minus 25 times negative 1, because I squared, folks, is negative 1. Remember that. And here we've got 16 plus 25. Oh, dear God, what is this? My mental math is terrible. You guys haven't figured that out yet. Oh, we get 41. Okay. Pretty cool. So that's it. I think there's a part missing for this next part. I'll have to redo that when I do the notes again. But hopefully you enjoyed this video. I had a lot of fun making it, and we'll see you later. Bye.